They are written in such a way that will satisfy, but they will not impress. Welcome back to Perpetual Jank Machine, the only podcast that is at the absolute last place on both of our priority lists. I'm John.
I'm Miles.
Miles, I want to talk about testing, the only thing that every developer claims to love and be an expert at, but as soon as they need to actually put pen to paper or bytes into a text file, it turns out in the most roughshod, terrible way you could possibly imagine.
I was gonna say, I was like, I don't do a lot of my debugging with pen and paper. I guess if you really need to walk through something and don't have a good debugger, then maybe.
I actually do a lot of console log debugging, to be totally honest, but that's a totally separate episode that I would like to get into, so we can add that to the list.
it's a, it's we're talking about testing, but that one's too specific. You got to save that for its own other day.
Well, it's kind of different. Like, testing and debugging are...
Oh, are they? I never considered that. I guess they are.
I mean, like, you don't have to be writing tests at all to be debugging a feature. I mean, arguably, testing and debugging is inversely related.
I don't get that one. No, I don't get that. No. Whenever you're debugging, you're testing things. And when you're testing things, aren't you looking for bugs?
Well, when you're testing things, you're trying to prevent bugs from cropping up in the future, right?
Yeah, but debugging's when those bugs are now. So it's the same thing. Just figuring out where it is.
It could be said that when you're testing, you are reducing the chance that you will, in the future, be debugging.
Oh, wait. So in your mind, testing is ensuring that there are no bugs, whereas debugging's finding out where those bugs are? Is that what you're saying?
What I'm saying is automated testing, like unit testing and integration testing and end-to-end testing. The big old test pyramid of tests that everybody claims to really enjoy writing.
Sure. Okay.
So if you have a robust automated test suite, there's a significantly lower chance that a change that you make is going to make it into production and then require you to do a whole bunch of firefighting and debugging frantically as your product manager looks on at you.
I mean, I guess, but half the time while you're writing the code, you screw something up and can't figure out where it is before it even gets into production.
Yeah, but that's kind of for the test to catch. I guess it kind of moves the debugging.
I feel like most testing is done whenever you're writing the code initially, just to make sure everything works the way you think it does. Like, oh, I did this line, and then I'm like, okay, let me just make sure it works properly, and then I do it, and then I realize it doesn't, and then I go back.
Are you talking about manual testing or automated testing with that?
Manual.
Okay.
Are we only talking about automated?
Well, I guess that kind of comes into another thing. We could talk about the balance of automated and manual testing, although honestly, I could speak about that for another 2 hours myself.
But it doesn't really catch any of the problems with your code. It kind of just catches when things just really don't work right. When it really gets something that it's not expecting, I guess.
So that is definitely an argument that you could make. I think, in my experience, it's actually relatively useful to catch corner cases. For example, if you have something that is supposed to be a certain way for a security reason or an accessibility reason, and it's not inherently obvious that that thing should be that specific way, and then you go and change something that breaks it, you may be unlikely to manually test for that thing in the future. I think that's really where, in my opinion, tests can be most valuable, is checking those corner cases that nobody thinks to check.
Yeah.
And they can help you define behaviors that are ideal for something in a way that is not code, or in a way that is talking about the feature and not talking about the implementation.
I mean, yeah. No, I think you're right.
So I think that is one of the values of testing. But the problem is that a lot of the time, tests are written in ways that have to conform to code that was not written to be easily testable, or the tests can be effectively just the bare minimum required to actually get the line covered, and then not actually test things that could cause serious problems.
I feel like people are half the time trying to defeat automated testing rather than use it.
Oh yeah, absolutely. And it's this pseudo-malicious thing where developers say, oh yes, we love automated testing, and automated testing is great, and it saves us a lot of time, and that makes their testers and their product owners happy. But then I feel like, and this definitely is not just me, I've seen a lot of terrible test code get into the main trunk. A lot of the time when the tests come up, they're an afterthought, and they are written in such a way that will satisfy, but they will not impress.
Yeah. Wait, are you talking about writing the tests or writing the code that is going to be tested?
Well, it's kind of a two-way street in that it's easier to test code that's written in certain ways, but I'm primarily thinking right now just about the quality of tests and the cases covered for those tests.
Yeah. I think the problem is tests, at least automated testing, they usually try to make it in a way that's sort of general. Obviously, that way it can be reused a lot. However, every individual piece of code usually is kind of funky in its own unique way.
So what do you mean by general?
I don't really know. I kind of lost my train of thought.
I was saying that even though some code can be written in ways that makes it difficult to test, and this is especially the case in compiled languages, people just don't test all of the cases that they should be testing, and they only test to the point where their code review will not be rejected due to lack of tests.
Oh, okay. So you might write a test that's like, okay, try zero, try negative numbers, like unexpected things. But if your code, say it's expecting a number between 1 and 360, right?
Mm-hmm.
They might only write a test that goes like, oh, try infinity, try not a number, maybe like, unexpected float values or stuff like that. And then they might not specifically test, oh, try a number greater than 360.
So they're testing the wrong cases, or cases that are not germane to the function's domain.
Yeah, like, it's just a lot of tests I feel like end up getting written to be like general. Not like all the time, but like I'm saying, yeah, like a decent chunk of the testing code is probably like that.
That is definitely a problem in testing not all of the domain. Like, I have this weird relationship with testing the entire domain of things, and that I feel like if your function accepts something in like a finite domain, or maybe a domain that consists of less than 10,000 things, like if your function accepts four numbers between 1 and 10, you take the Cartesian product of all that, all the permutations, that's 10,000 cases. Your CPU can run through 10,000 test cases in a millisecond. Why aren't you just testing every single case? And I feel like it's partially because that's kind of a pain in the butt to write, but also because it can be difficult to gather all of the data for all of those cases at once. And I wish that there was really a better way of going about things, especially with languages that aren't just pure functions. Because with a pure function, right, you can just apply it to the Cartesian product of everything, store the output, and then you can do it largely programmatically, if not in an automated fashion. But with a lot of things, if you have side effects, it can be really difficult to figure out what is going on in that function with all of its outputs.
Yeah.
That's definitely something that I wish people would do more, and I think is a great reason to write things in pure functions because it makes it relatively easy. But even if you're doing it that way, in my opinion, like if you have a function that takes, a certain domain, you should just have a thing in your IDE that just loads up a language environment, runs that pure function with every single argument in its domain, or, if it accepts strings, just a whole bunch of random strings and strings that are likely to cause problems, and then just stores the output. You can look over it and make sure that it's fine, and then it'll just write a test that says, okay, all of this is equal to all of this, and assure that that's always the case. And then if you go and break it in the future, then you'll know exactly what is wrong, and if that's not a problem, then you can just remove that test case because that clearly wasn't helpful to you. Or just update the result if it's a change in behavior.
I feel like the hard part of that is, like you said, then you've got to test the output. What output's valid? Like that might be a very complicated question. So you get a function, it inputs a value, and then it spits out a value. But what values are you looking for if you're testing every single possible output?
And this gets into a question of what are you likely to be doing with a function? Like obviously functions that accept strings, it's really difficult to find the cases for that, right? Because you actually need to be putting thought into it. Whereas with a number, you can just say like, what's the rough domain of this and then just test all the numbers in the rough domain of that, right?
Yeah.
But with a string, it's usually doing something specific. Like if you're doing sentence capitalization on something, you need to have multiple words. So you're expecting something that's going to have a lot of space characters in it, which a random generator is not going to know. So there is some intelligence that's required there, but I think once you start putting in these test cases, it's a lot easier to think of 20 test cases for a function than it is to think of 3 and then write tests for those 3. I think that putting all of your effort into finding these test cases is much more important than writing these tests manually, because writing these tests manually, if you're just testing a pure function, is something that can be totally automated. You can just test a tuple of input to output, and that should not be that difficult. Every test case for every pure function ever can be written in the form of, here is a list of tuples. The first item in that tuple is the input. The last item in that tuple is the output. And then for all the tuples in that list, assert that the function of the first item is equal to the second item. That's the test case for every single pure function.
Wait. Hold up. So you're saying write something that automates that, but that's the function, isn't it? That's a function's an input and then an output.
Mm-hmm.
So if you already have a piece of code that knows what the output is for every input, then you've already written the function. And if your function's not correct, then how are you going to know that your second time implementing this function is correct in your test?
You can also obviously write a couple of basic things that work on much weaker constraints. For example, I can say that splitting a string on the letter A, if that string has an A in it, then the list that is the output of that string split operation should not be of length 0. But that's a much weaker condition than just saying it should be equal to what it is equal to. And then when you go and break something, typically that test is going to, again, assuming you're writing reasonable test descriptions and not saying it does the thing, then you can go in and then you can intuit and say, hey, this case is not looking right. Why is that? Is it because I just changed the actual behavior of this function? And is that something that I wanted to do?
Okay.
Or is it unintentional and I just screwed something up? If you're splitting on like periods and all of a sudden you have strings with periods in them that are not being split on, then that's obviously wrong.
Yeah, okay, I get what you're saying. I thought you were saying like you write a new function and then you somehow have a list of like a tuple list of every input and every output. I was like, that doesn't make sense.
Yeah, not every input, but just the fact that you can test every pure function like that, and the fact that we don't have something that just automates writing that boilerplate that just goes, here's the input, here's the output, make sure they're equal. That would free you up to think of more inputs and outputs that would be worthwhile. And not even think of outputs, just think of inputs, and then run the function on it, look at it when you implement it, because you know what the function's supposed to do in your heart of hearts or your brain of brains, and say, oh, that looks good, or oh, that looks terrible, I should fix this function. That should be where all the effort goes in. It should not be in making sure that your test bed is working or making sure that the thing that you mocked is in this specific state at this specific time and trying to figure out why it's not. Like, that's 90% of test writing is just debugging the stupid crap that you need to get through to make sure that your test actually passes and doesn't flake. Because you know the code does what it's supposed to do. You've already looked at it and you've already called it with all the arguments that you can think to call it with. But just the idea of, there's always this little extra bit that you need to wrangle with, especially in side effectful things. I wish that we were able to write code, especially in the more enterprisey frameworks, in such a way that we don't have to deal with this nonsense and we can just go, okay, this is the input, this is the output, that's it. And that would be 90% of your code, and then you would have a whole bunch of crap that deals with the UI and the stores for your state. And that all needs to be tested the normal way, but that's only 10% of your tests. You're no longer dealing with any of these kinds of tests for logical things.
Couldn't you do that? Like even in compile code, when you compile it for debug, it's got references to all the functions and stuff like that. So couldn't you write something that... Yeah, I think you could do that. Even if it wasn't really focused on a code that wasn't written to be easy to test, as long as it has a function, I think it should be all right to test for, right?
Well, if that function has side effects, then how would you go about testing it with just comparing the input to the output?
Oh, I get what you're saying. You don't like testing with state.
Sort of, yeah.
Yeah, when everything's so intertwined with the state that it's really hard to test without it. I get what you're saying. Okay.
Or intertwined with the UI, because when you think about it, if you're testing some kind of like HTML producing code,
yeah,
your HTML DOM you can think of as just one other big state store that you haven't really accounted for, and you constantly need to go in and make sure in that massively complex store that things are actually sorted in the way that you expect them to be sorted.
I gotcha. So like someone's writing something and they could reference the global variable, or they could do it like through a pass-through kind of thing. You're saying just do it through the pass-through thing. That way it's not like dependent on that like global variable.
Sort of.
Yeah, so you're saying write as many functions as you can so that way it's just simple input, output, doesn't care about anything else. That way it's easy to test. And then for those edge cases where that's not the case, you're going to have to do something special to test those. But I get what you're saying. Write more code that just cares about input and output.
Yeah, specifically pure functions. And those are always the easiest things to test, is just the pure functions. Because,
Yeah.
again, it's just comparing input to output, usually.
Yeah.
And another way that you could go about making your code even easier to test is by making these functions that are a pain in the butt, generalizing them as much as possible and putting them all in one spot. So if you have a function that updates a store somewhere, like a state store, just have that be one function, one for the entire thing. And that function just takes effectively just a monad that tells you how to update your store. And then every single time you need to make sure that that store is getting updated, all you need to do is just make sure that that one function is getting called. So you can just continuously copy paste that thing around your code. And unfortunately, that's not really something that gets done a lot in enterprise code, at least in my experience. You always have a update this for this function and update that for that function. Or if you do have one function, you need to specifically specify a special monad that only works in this one specific case, when in reality you could probably just have it be a lens into the store instead of like being its own bespoke object or something like that.
Well, I think whenever you have like just one object controlling like everything, it gets confusing to write for. And so I'm not sure if I'm in favor of that, but I guess to its like own little section.
Well, if you just have one state object that just contains absolutely everything, then you can have this big global, almost kind of like I was talking about with pure functions, where you can just write a test that, let's say that this function updates a counter when you click on a button. What you can do is, in that case, you can just write the function, which, yeah, you're going to need some business logic in the test to make sure that you're clicking the right button. That's unavoidable, I think. But what you can do is then you can just say, hey, big universal state testing function, just make sure this is equal to that. Done. Instead of saying, either one thing you could do is you could either mock the dispatching to your store or mock the updating function, or you could write some custom code that peeks into your store and checks it, or you could just have one basic test function that just says, assert that the value at these keys is this. That's all you need.
How's that any better than like just having a whole bunch of global variables? If everything is all in one object, is that really any different than it just being accessible by everything all the time? Like everything's accessible by everything?
Yeah, that's kind of like the weirdest thing about code, is that people tell you not to put everything in global variables, and I kind of agree to that to some extent, in that global variables with like a plural S there is probably not the best way of going about it.
But whether I stuff them all in a struct or I just leave them outside of a struct, I don't think that really makes so much of a difference.
I mean, that's the way the industry's been going for the last little while, ever since Redux and ECSs were a thing. You see it in game dev, everything's in your big global ECS, and you can access anything at any given time, probably mostly for speed reasons. Or in your web dev project, you're using Redux, and all of your state is in one thing, other than is this modal being shown or something. That's usually component level.
I think the fact that people are just like, hey, screw it so much might not be the best argument for it.
Well, what's your other option? You've got encapsulation in OO. Like, how are you going to eliminate state? Your application would not exist if it were not for state.
Okay, like first off, screw object-oriented coding. Like, just screw it. Just like take it out back.
Well, what's the other option?
You're pretty in favor of functional, and it's just good old classic imperative, and just try to be careful.
How do you try to be careful with good old-fashioned imperative code when you have a whole bunch of state to deal with?
You try to only access the state for what needs it.
So where do you put that state?
Well, obviously, yes, you still need global variables. I'm just saying you try to keep it minimal. You try to keep certain things from not talking to it. Like occasionally you want to maybe pass it through like a function instead of directly through the global variable. Not necessarily all the time, but like, you know what I'm saying? Just be careful.
Well, that's kind of like what we do with Redux and ECSs. Like, obviously, your foobar component is not going to access the baz_quux key in your state. That would not be great. But just the fact that it's all available in one place, I think, is the main thing, because problems that state can cause for your code's reliability and ease of development are so great that it's actually just worth it to shove it all into one place and just try as hard as you possibly can to either pretend that it doesn't exist or make it easy to stub out and mock and stuff like that. If your entire app relies on one big state variable, you can effectively just dump it out to a disk in JSON or whatever, especially from the web, and then load it back up, and then effectively your app is in the same state. So you know exactly like what state your app is in at all given times, other than like, whether a modal is, unimportant stuff that's related to like, drop downs being open, modals being open.
Yeah.
Nobody really cares about that from a domain perspective.
Yeah, I'm not against like global variables and stuff like that. I'm just saying, why is that the conclusion you jumped to? Because it's all in one place, then what?
Because you can generalize. You don't have to write a bazillion different test assertions that say, okay, well, this variable is true, and this variable state is now false, and this variable state is now 27.5. You can just say, okay, in the store under these keys is 27.5, whatever.
I mean, I think what you want to do is be willing to not just call the global variable if you might have access to that data in some other way.
You have to update your state at some point.
Eventually, yeah. But like you said, you want to keep that to as minimal as possible. Occasionally, like you might want to like recalculate a value rather than just update a global variable, so that way you don't have to do that all the time. Like occasionally, for the sake of your code readability and testability, you might want to do stuff like that. That's all I'm saying.
Like duplicate the value of your global state? Is that what you're saying?
No, like I need to do this in this function and also some other time in this function. And then you come up with a bright idea. Oh, just come up with a global variable. And then after one calculates it, the other one won't. Like, obviously, that's like a terrible idea. That's like an unnecessary global variable. Like it's only used by two functions. And then you're like, oh, I'll save some effort and just make this global variable. Like, I guess for efficiency reasons, that might make sense. But in like a large program, that might get really confusing and might cause some really weird problems where one function might be affecting the other one in like, a weird way. So, I mean, obviously that's like a overly stupid situation, but like, you get what I'm saying? Like avoid doing stuff like that so you can keep your global variables to a minimum.
Well, is that global variable part of just some kind of incidental, possibly unnecessary implementation detail, or is it part of like the actual state that your app is in from a user's perspective? Because if your user's name is 4 characters long, let's say, and for some reason you want to do something if the user's name is less than 4 characters and something if the user's name is 4 characters or more, that is a perfect example of how something that was done in one function, specifically loading your user's name, is going to affect something that happens in the other function, and it's also a desired behavior.
Yeah. Okay. I agree that there are lots of situations where the state is important. Its actual state. Yeah. And in that case, obviously, yeah, you're not going to like be able to figure out the person's name from like something else, or even you wouldn't even want to do that.
It sounds like we're arguing for mostly the same thing, eliminating as much state as possible and then putting what has to remain by necessity into one place.
I don't get why you keep saying one place. I don't think it necessarily has to be one place. But I guess it could be one place. I guess it really doesn't make that much of a difference.
When you think about it, the address space of your program could be that one place if you want to get really cosmic about it. But
no. Yeah, I guess technically it all ends up somewhere.
I mean, having multiple names for different things from like a language level, I don't think is really the hang up here.
No.
I just prefer to have everything under one variable and just have it be a big map. But if you like multiple names, then that actually might make sense because it might be more performant for you if you're into low-level stuff.
I think we're saying that people are doing unnecessary things with the global state whenever they could just be purely functional is I think what we were getting at, right?
Mm-hmm. It all just goes back to functional things being easier to test and non-functional things being less easy to test.
Yeah, just do less bad programming, I think, is the moral of the story.
I mean, you can really think about it as a test is just a record of how your program behaves at this very moment, or a record of how you expect this program to behave at this very moment.
Yeah.
I think one of the main values of it is just being able to compare, however your program evolves over time, compare that behavior automatically without having to go through and test every single little feature of your program by hand.
Yeah, absolutely. I mean, yeah, there are plenty of times whenever you write your program, it's working great. You think, oh, I'll just change this one little thing. You test it, it works great. And then you find out later that thing broke something you would have never thought it could have broken. And to let that sneak up on you is obviously a very bad idea. So yes, I think testing's a great thing.
The way that we're currently writing our tests and that they are effectively small mini programs that are going about and mucking with different things and spying on different things and mocking out different things, I think that that's kind of fundamentally not the most efficient way of going about it because, frankly, writing tests in that way is fatiguing. I don't like doing it. I don't think any other developer, if they were being completely honest with themselves, would say that they like writing those kinds of tests. I think they see the importance of it, obviously, but in the way that it makes them feel deep down in their gut, it's not a great feeling to have to deal with a test that just you cannot get passing for some reason, even though you know the code is right, because you've gone through and you've tested everything manually, and those manual test cases are exactly what you wrote down in your test thing, and it's just some mock is being obstinate, or some kind of weird asynchronous thing is not completing in a way that it is realistically when you're running an event loop, and this is taking place over the course of multiple seconds or something like that. And that's just a pain in the butt. I feel like that's like the main reason that when I go to increase the code coverage threshold on a project, people start to groan. I think that's the main reason, honestly.
Yeah.
Because it really shouldn't be something that's annoying. That should make my life better, not worse.
Yeah. I think the problem with doing it so, I guess, less like hard coded kind of in a way is that if you change something about a program that like changes most of everything, then you basically have to like redo all your tests, which I guess is true anyway. But I feel like it's a bit harder whenever your tests are more like checking whether the previous input and output matches the new one.
Mm-hmm.
So if everything's changed, then basically you have to start from scratch again.
But I think that's another good argument for automation of at least the functional core. Because if you kill a function, even if you hard coded it previously, you're going to have to go in and delete all of those tests and then rewrite new ones around the new behavior.
Yeah.
Or if you sufficiently change a function's behavior, again, you're going to have to go through, and instead of just editing elements in a list of lists now, you're going to have to go through and actually rewrite this, again, small, tiny program that is written in this DSL that your testing assertion library and your unit testing framework is specified for you.
Yeah, I guess you do have to rebuild it either way. So I guess you're right. Yeah.
Just the ability to answer a question like, hey, is this right, is so much less of a mental load than saying, oh, this test failed because an assertion was thrown on line 36 because the first expectation of the test, expect 2 to be 3, is now no longer correct.
Yeah. How do you debug your tests then after you're done writing
Well, you
your
have
program?
same way that you do it with regular code, but that's a lot less of a mental load, is just
Well,
saying,
you should
instead
automate
of
that. You should automate your testing test.
especially if you write tests where you're even testing something that's functional and then you say, okay, well, first I'm going to make sure the return value is not null. And then I'm going to make sure that the return value is a list. And then I'm going to make sure that the return value's length is 3. And then I'm going to make sure that the first element of the return value is A, and the second element is B, and the third element is C. No, just assert that it's equal to a list of A, B, and C. Please. Please. Because all you're going to get when the test fails is expected this to not be null when it was null, or expected the length to be 3 when it was 4. When in reality, it would be a lot nicer to see expected this to be A, B, and C, but got null, or but got D, C, B, A. Because that's a much easier thing to look at from a list of problems.
Yeah. I get what you're saying. Yeah.
Like, I don't know why that's considered good practice. I genuinely don't. Like, people are like, always ramp up your assertions and make sure that you're testing it to make sure that it's not null first, and then you got to go do some other things about the property. Like, no, just say that it's equal, because that's the strongest condition that you're putting out. So hit me with that first, because that's the one that's going to come up in the testing debugger, and that's the one that I actually care about. I don't care that the length is 3. That has no basis on my business case. I care that it's A, B, and C.
Yeah, and I mean, I guess the advantage of that is if it's mostly right, like it's working mostly as you intended, but then like something like slightly screws up, then I guess that's slightly advantageous because then you know immediately, but not really all that much, because once it does break, you can just go in and test that one little specific example and figure out.
I don't even think it gives you value at all. Like, let's say that B and A got transposed. It's still going to fail on the assertion that the first element is A, and that's still not enough information. What you're doing is you're actually splitting up the assertions into these very tiny components, and then you're assigning like this weird bloody temporal element to it. Because then it could very well be that, for example, C is also screwed up. Like, let's say that C turned into D, but I wouldn't even know that until I fix the first assertion. And then I need to go back once the test is now failing again because C is D. And you need to, like, just one assertion, please. Just one assertion with the maximally stringent case.
Yeah, I can't really figure out what the reason for that would be. I guess it's a more natural way, because that's what you do whenever you like test a program by hand. So that's probably just why they do it that way.
Is it though? Because like when I'm going through something and I'm looking at something manually, like I added a new button or something, I don't like look at the page, but only to see that the button is there. And then I don't like blink and then go, oh, is the text on the button right now? And then I blink and I make sure, oh, is the color of the button right now? And then I blink and then I click the button and I make sure that, like, no, I'm going to go through it. If the button looks weird,
but while you're
that's fine.
writing the function, like when I'm writing a function, I'm like, okay, I want this function to first just output something. Like, you know what I'm saying? I'll hard code an output. And then, you know, whenever I'm writing it, okay, I'm like, okay, now I'll add a little logic. And then I'll make sure that works right. Sometimes whenever like people are first learning how to program, they don't like, you know, write a line and then like make sure everything compiles or like make sure everything works at least sort of okay. And then move on to the next line. That way you know which line like broke and it's not like this one giant function that you wrote has like 12 different bugs in it. So I think the idea of automated testing is you're mimicking the testing that someone would do by hand, but obviously automated. So I guess just like as tradition, you do it the way you would by hand. That's like the only reason I could think why somebody would do that, just because it feels right, I guess. It does seem like it feels right, but the more you're talking about it, the more it does seem to make sense that you wouldn't need to do that.
When I first saw that practice, I thought, oh, that makes sense. Okay, yeah, let's do it progressively. But then as I've used it more and more, it's like, what on earth are we doing? Like, why?
Yeah.
What is... Like, it feels right, but I think it's wrong.
Yeah, I think it's just tradition, man. I think it's just tradition. Like, probably the first person who wrote an automated test did it like he was doing it by hand, I guess.
So I guess the solution is to just rethink testing as it stands in general. And we haven't even gotten into UI testing or integration testing. This is just one small subset of unit testing your functional core and maybe your state transitions.
You had an agenda and you were getting at it.
I have an agenda for everything.
And I was slow at first, but now I'm on it, you know? I'm like, yeah, that makes sense.
Well, I'm glad to know that I've converted you. And that's the show. Thanks to Meydän, that's Meyda with an umlaut N, for their track The Beauty of Maths, licensed under the Creative Commons Attribution 4.0 license, which serves as our intro, outro, and interlude music. You can find more in the description of this episode. Please remember that the opinions expressed in this production may not reflect those of other participants on the show, or those of any participants' past, current, or future employers. They're also probably exaggerated a bit for comedy's sake. Anyway, thanks for tuning in.